Hello and welcome to Recitation. I am Leung, your recitation instructor. Now we are going to solve this problem number 11, which can be found in year 2. We have here a differential equation. As you can see, it is x squared y whole prime plus xy prime plus y is equal to 5x squared, where y or 1 is equal to 1 and y prime of 1 is equal to 3. So let's begin. First, we need to solve for the complementary solution. So here, the complementary solution. So we have x squared y double prime plus x y prime plus y is equal to nil. So as you can see, this is a linear Cauchy equation. We can solve this using linear Cauchy. So we have these formulas for m. So y double prime is equal to m minus 1 x raised to the power m minus 2 y prime is equal to mx m minus 1 and y is equal to x raised to the power m. So using these values, we can substitute directly to this equation. So we have x squared m minus 1 x raised to the power m minus 2 plus x raised to the power m minus 1 plus x m is equal to 0. Then we simplify. So this negative 2 here, x raised to the power negative 2 is obviously cancelable to x raised to the power 2. So we have this, we can cancel that. And then also this one, we can cancel the 1, the x. So we have x raised to the power, we have m of m minus 1 x raised to the power m plus n x equal to m plus x m x squared m is equal to 0. Then we factor out x to the m. X to the m minus 1 is equal to 0. We know that x to the raised to the power of m is not equal to 1, so we can be sure that the roots of this equation are in this polynomial. So here's m squared minus m plus 1 is equal to 0. M squared plus 1 is equal to 0. Then m equal to negative I. So we have here the complementary solution of C1 cosine of ln of x plus C2 sine ln of x. So we now have the complementary solution. Now it's time for the particular solution. So to solve for the particular solution, there are certain formats which you can apply to apply the undetermined coefficient method. And for this one, we'll apply, since this is 5x squared, there's a certain formula for this. So we'll use that. So y sub p is equal to ax squared plus b of x plus c. And then we'll get the first derivative of that, and we have 2ax plus b, and then the second derivative of that, we have 2a. So using this, we we can solve for the particular solution. So we start with here, x squared 2a plus x 2ax plus b plus ax squared plus bx plus c is equal to 5x squared. As you can see, I just substituted these values into this entire equation. So while we do that, we have x squared 2a plus 2ax squared, which is just the same as this, plus b of x or bx plus ax squared plus bx plus c is equal to 5x squared. And then simplified, we have 5ax squared plus 2b of x plus c is equal to 5x squared. From this, we can relate each term to this other side. As you can see, there is no c, so that's c is equal to 0. And then there's no b here, there's no second term here. So we can also conclude that b is equal to 0. And then 5ax squared, if you equate it to this term, 5x squared, then you can see that a is just equal to 1. Using these values, we can substitute it here, and then we find out later that 5b is just equal to 0, 0, 1 x squared. So we now have the y sub b and y sub c. So now we can get the value y of x. How do we do that? Well, assuming y of x is just equal to y sub c plus y sub b. So we can just add those two. So y of x is equal to c sub 1 cosine of ln of x plus c2 sine of ln of x plus x squared. Yes. And that's it. But there's more. We have to solve the particular equation, particular solution. Although this is the main particular solution, we have to get the particular solution of this, which we apply these values here. So how do we do that? Well, we could do that by substituting these terms here in this equation. So we start with y1 is equal to 1. So y1 is equal to 1. This way. So we substitute this, and we have 1 is equal to c1 cosine of ln of 1 plus c2 sine of ln of 1 plus 1. As you can see here, this one, so we can transpose this one, and we have this equation c1 cosine of ln of 1 plus c2 sine of ln of 1 to 0. You know, ln of 1 is 0. Cosine of ln of 1, cosine of 1 is 1. So we have here, we have c1 plus 0 is equal to 0. So we have c1 is equal to practically 0, nothing. And then moving on to get c sub 2, we use this equation to find c sub 2. So we have here 1. So in order to apply this, we have to get the first derivative of this equation. So we have this 1 equal to negative c sine of ln of x plus c2 cosine of ln of x plus 2x. So we'll just substitute all of this. So we have 3 plus is equal to negative c1 0. So this is nothing. So this is 0 plus c2 cosine of ln of 1 2 transpose. We have 1 is equal to c2 cosine of ln of 1, which is just 1. So we can conclude that c2 is equal to 1. So we already have c1 and c2. Now we can see the final answer. So we have the final answer of y of x is equal to sine of ln of x. Yes. Plus x squared. We apply these values, all of them applied here, and we have this final answer. And that ends my recitation.